All right. So this time we're going to focus in on angle side proofs. But again, if you prove them because of angle side, you can actually add on another up here within your proof. You can really have angle side angle happen in the end if you kind of add like a 2.5 step in here about the third angles theorem. But again, all these proofs really should be done with angle side. Adding in that third angles theorem to get to the other one just really makes this a 4-step proof instead of a 3-step proof. But again, because these are angle side proofs, you can make them angle side angle if you just talk about the third angles before them. Okay? But that's neither here nor there. I just wanted to let you know that. These are just angle side proofs. So again, write out your given, mark stuff in your picture, try these proofs. They're pretty short. This proof up here, I'm highlighting the fact about parallel lines. And this proof, I'm going to highlight the fact about vertical angles and things like that. Okay? So something that we've kind of marked before, just like when we talked about the reflexive. All right, so try these proofs. They're all angle side. So you should have two angles congruent and a side congruent. Okay? So just writing out my given the way I see it up above. Okay, so we got segment AD parallel to segment ME, segment DM parallel to segment EB. Again, this is all given. We also have segment AD congruent to segment ME. So we know that this is congruent to that guy. We also know that they're parallel, and that's a symbol for parallel right there, that filled in triangle. We also know that this side right here, and I got to use two triangles for that, it's parallel to those two sides. Okay, so there's everything marked in my picture. These are my parallel symbols. There's my congruent symbol, parallel, parallel. Okay, now with parallel lines, you're going to be looking for one of two things. You want to look for either corresponding angles or alternate interior angles. Okay, those are really the two that are going to happen in triangles. So when I look at this, you got to kind of imagine, I'm just going to focus in on these two lines right there. So here are my two lines that are parallel that I've talked about above. Okay, and there's like a transversal for them. Okay, so if I look at this, look at these angles that are right here. Those two angles should be congruent to each other. Those two angles that I starred are right here. Angle DAM congruent to angle EMB. And what kind of angles are these? And they are congruent, that is true. What kind of angles are those? Well, those angles are what we call corresponding. Okay, because they're in the same spot. Corresponding means that they're in the same spot. It's like the top right-hand corner, Okay, so what I make my students write out, I make them write out the full statement. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Now, if you got my list of reasons, they would just call this the corresponding angles theorem, or corresponding angles postulate, or corresponding angles converse theorem, corresponding angles converse postulate. That's what you'd be looking for on your assignment, or aka your homework, or the quiz, or the test. I just make them write it out because no one can ever remember whether it's a converse, a theorem, or a postulate. It's just junk, so I make them write it out. But you don't have to write it out because obviously you've got my list of reasons that you can look at, and they're all written there for you. So if we look at what we got so far, we know that we need angle side. I've got one angle, got one side. There's got to be one more piece. Well, that goes with our other set of parallel lines. Again, if I kind of draw a picture out of those lines, they look like this, kind of reverse directions. Do we see anything that they would have in common? Okay, so these are my other parallel lines that are drawn in my picture. Absolutely. It's this angle that's right there. This guy. Sometimes it helps to dissect your picture and draw them out. So what kind of angle is this guy? Right, again, it's back to corresponding. I call this my mountain picture. Whenever you have two triangles side by side and you got mountains like this, okay, peak and a peak, two sides, and you got parallel lines, usually what you're looking for in this guy is corresponding angles, okay? It's a pretty dead giveaway. And since these are corresponding angles, I'm just going to keep them in the same step that we had right here because it's the same reason, and there's no reason to make another step for it. You can if you want, but there's no reason. So this angle is DMA, and it should be congruent to angle EBM. So there's my other angle, and if you look at what we got, here's my angle, and then there's my non-included side. So yes, this is angle, angle, side. But again, if you talk about that third angles theorem I talked about earlier, you now know that D and E are congruent. You could do angle, side, angle, but there's no need because this is just an angle, side proof. So AAS, triangle ADM, congruent to triangle MED. So the parallel ones, you just got to be careful. So usually when you got mountain triangles, this is where you're going to see those corresponding angles pop up on you. Okay. All right, down here we've got segment AB congruent to segment ED, and we got angle A congruent to angle E. All right, so let's do some marking up here. We've got AB, ED, got angle A, angle E congruent. So we've already got one side, one angle, and this is all given. Really, all we just need is one more angle. And where is that at? That's right, it's right here. This is our vertical angle. Remember, that's why I highlighted this one. This is all about vertical angles. So we now know that angle BCA, and I got to use 3 letters because there are tons of angle C's here. BCA congruent to angle, well, let's match up here. B matches up with D, C matches up with C, A matches up with E, so DCE. And that is your vertical angle theorem. Vertical angle theorem. Vertical angle theorem just says that all vertical angles are congruent, kind of like our right angle congruence theorem, okay? Where it said all right angles are congruent. Well, here, this just says vertical angle theorem, all vertical angles are congruent. And that is a vertical angle. There's my second angle. And so now I know my triangles. Triangle ABC congruent to triangle EDC. Done.